Math is great.
Okay, in this video we're going to look at the Pythagorean Theorem. It's a well-known theorem that many people watching probably already know, but we're just going to do a review of it and make sure we understand the concepts behind it. We're also going to look at a couple of special cases of right triangles and validate them via the Pythagorean Theorem as well, and then we're going to use that information in some future videos. Alright, so the Pythagorean Theorem is a theorem based on right triangles. Many of you know it as something that looks like this: a squared plus b squared equals c squared. So let's look at a kind of a graphical representation of this. So we have a triangle with a right angle, and what we're going to do is we're going to take each of the sides and form a square out of it with the length of that side. So we'll take this side and make it a square. These aren't perfect squares. My hand drawing capabilities don't make perfect squares. Sorry about that. And then we'll do another one here. Just assume these are squares. And then let's make this one a nice yellow color. Do this one here. Okay, so now we have three squares that we created off of the three different sides of this triangle. So what are the areas of these squares? Well, the area of a square is its side squared. So if we call this side here C, then the area of this square, the area, equals C squared. We call this side A, and the area of this side is going to be A squared. I'm denoting area with a capital A here. And then this purple square, we're going to call that side B, so the area of this square is going to be B squared. So what the Pythagorean theorem tells us is that if we add the areas of these two squares that we made for sides A and B, they're going to equal the sum of those two squares. Areas is going to equal the area of our square on side C. And that's where we get the formula a squared plus b squared equals c squared. So let's look at just a couple of examples real quick. So basically, using this formula, if we know two sides of a right triangle, we can solve for the other side. So if we look at a triangle here, let's make a triangle, a right triangle, and we'll give one side the length 5 and the other side the length 12, and we want to know what the hypotenuse, or C in this case, is. So we just use our formula here: a squared plus b squared equals c squared. So we're going to get 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. 169 equals c squared, and then we take the square root of both sides. We get 13 equals c. So c equals 13. Let's do another one real quick just to make sure we understand the math. So again, we have a right triangle here, and in this case we're given that the hypotenuse is size 5 and one of the sides is size 3. So what is this side equal to? Well, we set up our equation. We have one of the sides, we call it A, so we'll call that 3 squared. This side is B. I'm going to put B squared, and then that equals to 5 squared. Alright, so we have 9 plus B squared equals 25. And we can subtract a 9 from both sides. We'll get b squared equals 25 minus 9 is 16. And then if we take the square root of both sides again to get our b, we'll get b equals 4. So in this case, b equals 4. So there's a couple of examples using the Pythagorean theorem. Alright, so now let's look at a couple of special cases of right triangles. So I'm going to call this first triangle, we're going to call it a 30, 60, 90 triangle. So you can maybe guess what that's going to look like. We have a right angle, which is our 90, and then we have two other angles, one that's 30 and one that's 60. We know that a triangle has all the angles in the triangle have to add up to 180, which they do here. So what does this give us above and beyond just the standard right triangle? Well, in this case, for a 30, 60, 90 triangle, we only need to know one side of the triangle to be able to solve for the other two sides. So what we have is the side that's opposite of the 30-degree angle, which is this side here, this side right here that I'm marking yellow. That's going to be x. Now the side that's opposite of the 60-degree, I'm marking here in purple, that's going to be x times the square root of 3. And then the hypotenuse here, which I marked in this peach color, that's just going to be 2x. So if we know any side of a 30, 60, 90 triangle, we can solve for the other two sides because we have formulas for all three sides based in x. So let's look at a real simple example here. I'm going to make a right triangle. That's a 30, 60, 90 triangle. And I'm going to say my hypotenuse is of value 2. Okay, so if my hypotenuse is value 2, then my side opposite the 30-degree angle is going to be half of that, so that's just going to be 1. And then now I have what my x equals 1, and then my other side is just going to be 1 times the square root of 3, or the square root of 3. And let's use our Pythagorean theorem real quick just to check this. So we have a squared, 1 squared, plus the square root of 3 squared equals 2 squared. So 1 squared is 1. The square root of 3 squared is just 3. And then 2 squared is 4. So that's right. Alright, so that's the 30, 60, 90 triangle. Alright, now we're going to look at a 45, 45, 90 triangle. Well, now you definitely can guess what this one's going to look like. It's going to be a triangle, a right triangle, where both of the angles are 45. Both of the non-right angles are 45. So in this case, again, we have a formula that we can know for, if we know one side, we can find the other sides. So because both these angles are the same, both the sides opposite the angles are going to be the same as well. So we're going to call this green one x, and then we'll call this purple one also x, because they're both opposite the 45-degree angles, they're both the same length. And then the hypotenuse in the 45, 45, 90 triangle is going to be x times the square root of 2. Okay, so let's again look at an example of this. So we're going to make a 45, 45 triangle here. And I'm going to say this side is 1. Well, what are my other two sides? Well, this side, I know it's also x, so it's also going to be 1. And then my hypotenuse is going to be x times the square root of 2. Well, x equals 1 here, so that's just the square root of 2. Alright. Now, same thing we had before, we can validate this with the Pythagorean theorem. We have 1 squared plus 1 squared equals the square root of 2 squared. So we get 1 plus 1 equals 2, and that is correct. All Alright, so we did a little review of the Pythagorean Theorem. We looked at a couple of special cases of right triangles where we can find sides even only knowing one side. And we'll use this information in some future videos as we get into some more advanced topics.